All right, you guys, let's do one more example of graphing rational functions. So we're going to walk ourselves through the similar steps that we've done in the previous videos. We just have a new function this time. All right, so we already know for step one, they're going to want us to factor the numerator and the denominator and write it in its factored form. So let's write the function. So we have f of x All right, so we need to completely factor the numerator and the denominator. So in the numerator, that can be factored as x. We need factors of 10 that are going to give us 9. That's going to be 1 and 10. I need a negative 9, so the 10 is going to be negative, the 1's going to be positive. And the denominator is already factored as far as it can go. So yes, we can write it in its factored form, and we will write this in its place. All right, let's do step 2. So step 2 says to find the domain. Remember, anytime you're looking for the domain of a rational function, the denominator cannot equal 0. Okay, for the domain. All right, so we're going to set our denominator equal to 0 and solve. So we have x plus 5. Oops. And we're going to solve for x. I'm going to subtract 5 from both sides. So x equals negative 5. All right, so that means I can plug in anything I want into this function as long as x doesn't equal 5. So if I wanted to write that in step builder notation, I would have brace x such that x does not equal negative 5. All right, so when I go back over here and I look at the choices, I'm going to choose C because x does not equal negative 5. Okay. All right, let's continue on to the next part. So the next part wants us to write our function in lowest terms. Okay, so remember, lowest terms means that you have no common factors in the numerator and the denominator. We already factored our function here, and there are no common factors in the top and the bottom. So we can answer this as that our function is already in lowest terms. Okay. All right, for the next section, they want us to find the intercepts. Let's change our color. All right, so remember we have two different types of intercepts. We have x-intercepts and we have y-intercepts. To find x-intercepts, you set y equal to 0. Okay, so everywhere in our function where I see y, I'm going to make it 0. And I'm going to solve. So I can put 0 over 1 and cross multiply. So I have 0 times x plus 5, which is 0, and 1 times the numerator, which is going to give me x plus 1, x minus 10. All right, since they're already factored, I'm going to set each of those factors equal to 0 and solve. All right, so I have two x-intercepts, negative 1 and 10. So as coordinates, that would be negative 1, 0, 10, 0. All right, and I also have to find my y-intercepts. So to find y-intercepts, you set x equal to 0. So everywhere in that function where I see an x, I'm going to make it 0. So in the numerator, that's going to give me 1 times negative 10 over 5. So negative 10 over 5 gives me negative 2. So I have one y-intercept at 0, negative 2. Okay. All right, so let's fill that in. So my graph has x and y-intercepts. My y-intercept was at 0, negative 2. Oh, so it just says write the integers, not as coordinates. So negative 2. And then my x-intercepts were negative 1 and 10. Okay. All right, next part. They want us to determine the behavior of the graph at each x-intercept. Okay, so let me change my color. All right, so remember the behavior at the zeros or x-intercepts is determined by the multiplicity. If the multiplicity is even, that means our graph is going to touch. If the multiplicity is odd, it means our graph is going to cross. Okay, so these were our zeros, our x-intercepts. Okay, so we need to look at their multiplicity. So you look at the degree on the factor where that 0 came from. So -1 came from this factor where the degree is 1, okay? And 10 came from this factor where the degree is also 1. So our multiplicities are 1, and 1 is odd, which means that our graph is going to cross at each one of these x-intercepts, okay? So let's look at our answer choices. So they want us to describe the behavior. So it says the graph will cross and touch, but not cross. Let's see, the graph will cross, the graph will touch, but not cross. Cool, so we want to say it'll cross. Okay, it's going to cross at both -1 and 10. All right, cool. All right, let's keep going. All right, the next thing they want us to do is find vertical asymptotes. Okay, by now you guys should know that vertical asymptotes, to find them, you set the denominator equal to 0. All right, and then you solve. So our denominator was x plus 5 equals 0. We're going to solve for x. So x equals -5 is our vertical asymptote. So we would say it has one vertical asymptote at x equals -5. And I wrote it as an equation because the directions say type as an equation. Okay. All right. Now they also want us to determine the behavior of the graph on either side of the vertical asymptote. Okay. So remember, the behavior at the asymptote is also determined by the multiplicity. Okay. If the multiplicity is odd, our graph is going to clash, which means it's going to head to opposite infinities. If the multiplicity is even, it's going to clap. Okay, so if we look at where our vertical asymptote came from, the degree on this factor here, okay, is 1. So our multiplicity is 1. 1 is odd. So our graph is going to clash, okay, which means it's going to head towards opposite infinities. Okay, so if we go back over to our answer choices, determine the behavior. Let's see, A says it approaches infinity on one side and -infinity on the other. So this first choice is saying that you would have an asymptote that clashes and claps. We don't have that. It approaches either positive or -infinity on both sides. That's saying that both of them are clapping. And then C says it approaches infinity on one side and -infinity on the other. That's what we have. We have an asymptote that clashes. So it is at x equals -5. Okay. The next section wants us to determine whether or not our graph has a horizontal asymptote. Okay. So let's go back up and look at our function. All right, so if we're looking at this function, remember you determine horizontal asymptotes if the degrees are the same or if the larger degree is in the denominator, okay? But as you guys look, so let me rewrite it for you actually. Let's scroll back down. It was minus. All right. Okay, so our function was f of x equals x squared minus 9x minus 10 over x plus 5. All right, so we're looking at the degrees. So the degree in the numerator, okay, is 2, and the degree in the denominator is 1. You don't see an exponent there, so it's understood to be 1. So the larger degree, okay, is in the numerator. Okay, so since the larger degree is in the numerator, we're not going to have a horizontal asymptote at all. So we have no horizontal asymptote, okay? So we have no horizontal asymptote, but that does tell us that we are going to have an oblique asymptote. Because the larger degree is in the numerator, okay, we're going to have an oblique asymptote. Okay. So we already know, yes, we have an oblique asymptote. Okay, so in order to find it, okay, we're going to have to use long division. Okay, so we need to set that up. Let's change colors. All right, so we're going to divide the numerator by the denominator. So we're going to have x squared minus 9x minus 10 divided by x plus 5. Did I write that correctly? Yes. All right, so remember when you're doing long division, okay, you're looking at the first term in the divisor and the first term in the dividend. So you're going to ask yourself, what times x is going to give me x squared? Well, x's, okay? You're going to take that x that's in the quotient and you're going to multiply it by every term that's in the divisor. So x times x is x squared. X times 5 is 5x, okay? You're going to subtract. So I like to say, draw the line, change the sign. So you're going to subtract. And that subtraction is going to change the signs of the terms that fall behind it. So this is now negative, and so is this. So when we combine, the front two terms cancel. All right, and we have negative 9x minus 5x. That's going to be negative 14x. And this negative 10 is going to drop down. Okay, we're going to do it again. We're going to look at the first term in the divisor and the first term in the polynomial that's left behind. So what times x is going to give us negative 14x? Well, that's going to be negative 14. And you're going to take that negative 14 and you're going to multiply it by every term that's in the divisor. So negative 14 times x is negative 14x. Negative 14 times 5, that's 50 and 20, negative 70. All right, and then you're going to draw the line, change the sign. So you're going to subtract. It's going to change the signs. You're going to combine. These front two terms are going to cancel. And it's going to leave you with negative 10 plus 70 is 60. Okay, and you can't go any farther because the degree in the divisor is larger than what's left in the remainder. Okay, so when they ask us for where the oblique asymptote is, okay, the oblique asymptote is always y equals whatever the quotient is once you do long division. So ours is going to be y equal this part, x minus 14. Okay, we don't care anything about the remainder. All right, all we care about is the quotient. All right, so we have an oblique asymptote at y equals x minus 14. So we have one oblique asymptote at x equals, y equals x minus 14. Okay, cool. All right, the next section wants to know if our graph is going to intersect our horizontal or oblique asymptote at any point. So remember, if you want to find out if they intersect, you need to set your equation that you've been given, your function, equal to your asymptote. So we're going to set f of x equal to our oblique asymptote. So our function was x squared minus 9x minus 10 over x plus 5 equals x minus 14, because that was our asymptote, okay? So we're going to cross multiply. So we have x squared minus 9x minus 10 equals x plus 5, x minus 14. All right, we're going to have to FOIL the right-hand side. So that gives me x squared minus 9x minus 10 equals x squared minus 14x plus 5x minus 70. All right. This is now a quadratic, so I need to combine like terms by putting in standard form. So everything that's on the left, I'm going to move to the right. Minus x squared plus 9x plus 10. So 0 equals, the x squared terms are going to cancel. I have negative 14x plus 5x plus 9x. So all of those cancel each other out. And then I'm going to have negative 70 plus 10 is negative 60. Okay. This is a contradiction. This is not true. So there's no intersection. Okay. So we're going to come back over here. And we are going to look at our answer choices. So A says the graph of f intersects. Nope. The graph of f intersects. Nope. There is no point at which the graph of f intersects the horizontal. Yep. It will not intersect. Okay. All right. The next part says use the real zeros of the numerator and the denominator of f to divide the x-axis into intervals. And then they are interested in where the graph sits either above or below the x-axis. All right. So when you guys are determining this, let's slide over. All right. All right. So we're determining. Okay, so we're determining where the graph is above or below the x-axis. To do that, you're going to place your x-intercepts, your vertical asymptotes, and any holes. All right, so we had x-intercepts. Where were they? Our x-intercepts were -1 and 10, and we had a vertical asymptote at -5. So -1 and 10. And -5, no holes. All right, so I'm going to draw a number line, and I'm going to put my values on there the way that they naturally would occur, so smallest to greatest. So -5, -1, and 10. All right, that splits my graph into 4 intervals. Those intervals are -infinity to -5, -5 to -1, -1 to 10, and 10 to positive infinity. All right, now I need to choose test points. It doesn't matter what I choose. I just need to make sure I choose a test point that actually falls in that interval. So for here, I'm going to try -6. This one I can try -2. Let's do 1 and 11. Okay, so I'm going to take those test points and plug them into my function to see if I get a value that's positive, which means that I would be above the x-axis, or negative, which means that I would be below. Okay, so let me write our function over here again. So f of x is equal to x squared minus 9x minus 10 over x plus 5. Or you could use the factored form, doesn't matter. Minus plus x plus 5. All right, so I'm going to plug my test points into that function to see if I get positive or negative values. All right, so let's try -6. So -6 plus 1, -6 minus 10, -6 plus 5. All right, so I don't particularly care what the number is. I'm just interested in the sign. So -6 plus 1, that's a negative. That's going to be a negative. And this is negative. So a negative over a negative is negative times a negative is positive over a negative, which would be negative. All right, and since it's negative, that means I'm going to be below the x-axis. Okay. For the second one, -2 plus 1. So let's see, that would be negative, negative, positive. Positive over a positive would be positive, which means I'm going to be above the x-axis. All right, if we try the second one, move over a little bit. 1 plus 1, 1 minus 10, 1 plus 5, positive, negative, positive. Positive times a negative is negative. Over a positive, that's negative, which means I'm below the x-axis. Then my last interval, I'm trying 11. 11 plus 1, 11 minus 10, 11 plus 5. That's positive times a positive over a positive, which means I'm above the x-axis. Okay, so I have 2 intervals where I'm above the x-axis and 2 where I'm below. So let's see if we can answer that question. All right, so the graph of f is above and below. So I want to choose the first choice. And I was above the x-axis from -5 to -1. And my other one was 10 to positive infinity. And then the intervals where I were below, that was from -infinity to -5. And -1 to 10. Okay. All right. Then the last part, we have to pick the right picture. Okay. All right, so we already know we're going to put all the information that we have so far into picking the right picture. So we only had one vertical asymptote. So all of these have one vertical asymptote, but our vertical asymptote was at x equals -5. So automatically B is out because its vertical asymptote is on the positive side. So I already know that's out. And so is C. C's out. All right, we also had an oblique asymptote, which another word for that is a slant asymptote. Both of these have oblique asymptotes at the same spot, so we can't eliminate from there. But now we're going to look at the signs of our function. So let's pull out the highlighter. All right, so we said that our graph should be above the x-axis from -5 to -1. All right, so -5 to -1, I should be above. So that means I should have something that looks like this on this side. I should be above the x-axis. All right, so that one, let's see, -5 to -1, and we should be above from 10 to infinity. So that's above. That looks like it's above. All right, let's see, we should be below from -infinity to -5. So below -infinity to -5, above -1 to infinity. This one is on the right spot. So let's see, this one, are we below or above? We're not in the right spot for D. So D is out. So our interval said we should be above the x-axis from -5 to 1. So let me do that in a different color so you guys can see. All right. So we should be, all right, we should be above from -5 to -1. So that's here. So we're above the x-axis there. We should also be above from 10 to positive infinity. So that's there. All right, we should also be below from negative infinity to negative 5. That's here. All right, and from negative 1 to 10, that's in here, this little piece that's underneath. Okay, so as far as our pictures go, A is our choice. All right, I hope this helps.